Hello, we are discussing about GATE 2008 ECE paper, and this question is related to analog circuits. Look at the diagram given. Consider the following circuit using ideal op amp. The current voltage characteristic of the diode is given by the relation of I is equal to I naught times of e power V by Vt minus 1, where Vt is equal to 25 millivolts, I naught is equal to 1 microampere, and V is the voltage across the diode taken as positive for the forward bias. For an input voltage V of minus 1 volt, what is the output voltage V naught? V naught we are going to calculate whenever Vi is equal to minus 1 volts. So V naught implies nothing but V naught is nothing but voltage across output node, that is from that point towards ground. So this is plus minus. V naught is nothing but output voltage from the output node towards ground. So towards ground is nothing but, because it is ideal op amp which supports virtual short, that implies nothing but the voltage at both the terminals are going to be exactly same. Okay, virtual short implies nothing but voltage at non-inverting terminal and voltage at inverting terminal are going to be always equal. Okay, that is because of one of the important characteristic of ideal op amp, that is nothing but AV is equal to infinite. Okay, since AV is equal to infinite, voltage gain, open loop voltage gain is infinite, that you can write it as output voltage divided by the input difference signal. So from this one you can write it as VID is equal to V naught divided by AV, which is nothing but V naught divided by infinite, that is nothing but 0. So VID is nothing but, you can write it as voltage at non-inverting terminal minus voltage at inverting terminal is equal to 0, that is V plus is always equal to V minus. This concept is going to be called as virtual short. Okay, so voltage at inverting and voltage at non-inverting terminals are same. Since voltage at non-inverting terminal is given at 0 volts, so this is also at 0 volts. So by that time 0 volts implies nothing but ground. So this inverting terminal is also at ground. V naught can be calculated. Instead of going in this way, you can also go in this way, from output node towards ground node, that is nothing but towards inverting terminal. So whenever you are going in this way, this is what the method you are going with. V naught we are going in this way. By that time voltage drop across 4 kilo ohms plus voltage drop across diode, that is V. So output V naught can be written in this way. V naught is equal to voltage across 4 kilo ohms plus V, which is nothing but voltage across the diode. Voltage across 4 kilo ohms is nothing but current flowing through that one. Assume it as I. Current flowing through the 4 kilo ohms is I, and multiplied by the 4K plus V. So where I is equal to, I implies nothing but the current flowing through this resistor, and that makes the diode forward bias, and the same amount of current, okay, it is also flowing through this 100 kilo ohms. Because the current coming from this feedback branch, it won't go into the input terminals of operational amplifier. It never enter into inverting terminal of op amp because of infinite input impedance. Ideal op amp has infinite input impedance, that implies nothing but zero internal currents. So no current is going to be taken by the input terminals of op amp. So entire current which is flowing through 4 kilo ohms and diode, that is also flows through this 100 kilo ohms. So if you are able to calculate the current flowing through this 100 kilo ohms, that is the current which is flowing through this 4 kilo ohms. Okay, so now we will calculate the current flowing through this 100 kilo ohms. Current flowing through 100 kilo ohms you can calculate by going through the voltage difference across that resistor divided by the resistance value. So high voltage is going to be, current is coming from this one right to left. So 0 volts is nothing but high positive voltage, and this side left side is nothing but minus 1 volt. So I can be written as 0 minus of minus 1 divided by 100 kilo ohms. Okay, that implies nothing but I is equal to, you can get it as 10 microamperes. So I value is known. and this is the I value which is going through this diode also. So the diode current given the equation, from the given equation, diode current id is equal to I, which is nothing but 10 microamperes, and that you can express in terms of I naught into e power v by vt minus 1. So 10 microamperes is equal to I naught is nothing but 1 microampere multiplied by e power v by 25 millivolts. So 25 millivolts is nothing but 0.25 minus 1. From this one, if you simplify, you are going to be getting v is equal to 0.06 volts. So if you calculate this one, you will get the v value as 0.06 volts. From this one, you can calculate v naught is equal to, going through this loop, okay, I into I times of 4k plus voltage across the diode. I times of 4k is nothing but 10 microamperes. 10 microamperes into 4k plus 0.06. So this you are going to be getting it as 0.04 plus 0.06. So total is nothing but 0.1 volt. So the output voltage is going to be equal to 0.1 volts. 0.1 volts is nothing but answer, right answer is B. Okay, the output voltage for the given circuit is nothing but 0.1 volts. Thank you.